Hi viewers, this is Sri Ramulu. So today's topic is current components in transistor. Okay, so what are the current components are there in transistor? The side figure is given. Here it is a figure given. Okay, so first let me explain. Later I will show you. The figure shows that the various current components which flows across the forward biased emitter junction, reverse biased the collector junction in PNP transistor. Okay, the emitter current consists of following 2 points. What are those 2 points? First point, whole current IPE constituted by holes crossing from emitter to emitter into base. Actually, if it is what type of transistor, it is given PNP transistor. PNP transistor. Here majority charge carriers are holes. Holes has to enter into the base. Then current produces. That current is denoted by IPE. So it is a current because of hole coming from the emitter. Okay, next, second point, electron current I and E constituted by electrons crossing from base into the emitter. Here, when holes are moving in this direction, opposite to them electron moves. Okay, when electron moves, then current constitute. That current is denoted by I and E, entering into the emitter. So what current, that is because of electrons. N means electrons, negative charge particles. P means positive charge particles. Now total emitter current can be written as this one. Okay, so a current is this current entering into the base, and this current is coming to the emitter from the base. Next, in commercial transistor means such as in systems or in computers or in mobile phones, like this, the doping of emitter region is made much heavier than the base. And see here, doping level of emitter in commercial transistor, doping level of emitter is very much high, okay, than the base. Hence the electron current component I and E, electron current component I and E, sorry for the disturbance. Okay, yes. Right. So in commercial we have seen, in commercial we are okay. Next, hence electron current component I and E, electron current component I and E negligible, small in comparison with the whole current. Okay, why whole current is why we are neglecting this one? Because here emitter is heavily doped. So when heavily doped, then large number of holes will present. Then comparing to the whole current, electron current is less. Okay, next. Thus, in comparison, in commercial PNP transistor, emitter current consists of almost entirely holes. So because of that, what happens? Emitter current is because of only hole. In PNP, okay, not in NPN. A few hole crossing the junction JE. Where is the junction JE? See here the diagram. In the diagram, junctions are given. That is emitter junction. It is emitter junction. Okay, it is JC, collector junction. See here JE, JC are given. JE, JC. Okay, it is emitter junction, it is a collector junction. PNP transistor, emitter base collectors. Here the currents are, this is a IPE whole current, it is INE due to the minority charge carriers electron current. Same thing this side also. Okay, and this is, see here one thing, emitter junction is JE, once again collector junction is JC, this side is IB current, IC current, IE current, and it is IC current. Okay, these are the batteries. Next, okay, a few holes crossing the junction JE combine with the electrons in n-type base, rest of them cross the collector junction. Okay, so we know that it is a p-type, n-type and p-type. So here a whole current more and enter into the base, and a few electrons, just now I explained you, the around 1 to 2% of holes recombine, and remaining 98 to 99% of holes enter into the collector region by crossing JC. It is JC, it is JE junction, emitter junction, collector junction. Next, to reduce the number of holes so lost through the recombination with the electrons in n region, the width of the base region is kept extremely small. So if you want to minimize the recombination, then what we have to do, we have to make it is very thin. Okay, then what happens, very less holes recombine with this, and a mostly large number of holes enter into the collector region. Now let IPC be the whole current at junction JC. So IPC, why it is a current because of hole entering into the collector. The difference IPE and I minus IPC is the recombination current IB, which leaves the base as shown in figure. So their difference is what? That is the base current denoted by IB. If emitter were open, emitter region is opened, then emitter current cannot flow. Opening means we are not giving any voltage. Then IPC would be 0. So that means the current which is entering from base to collector, that is IPC. Under this condition, the base and collector together act as a reverse diode. So then this region can act as reverse diode, reverse biased diode, that is the meaning. And the collector current IC equal to the reverse saturation current IC. So when a diode in reverse bias, then what happens? We know the reverse current flows. That reverse current is after certain time it becomes saturated, means maximize. That is denoted by here ICO, which consists of the following two parts. Okay, ICO consists of two parts. One is INCO, caused by the electron moving across JC, caused by the electron moving across JC. It is JC. This junction is JC junction, collector junction. From P region to N region. P region to N region means like this. Next, IPCO, caused by the hole moving across junction. Same here also, but it is in opposite direction. From N region to P region. So like this, from base to collector. Then ICO can be written as their two combination like this. In general, we write it is like this. By removing O value, O term, IC is equals to INC plus IPC. Thus, a PNP transistor having the formula IE is equals to IB plus IC. It is a very, very important form. Base collector current is always combination of base current and collector current. Sorry, emitter current. Emitter current is always combination of base and collector. Okay, don't forget, it is very, very important form. Next, there is a relation between alpha and beta. What are the alpha? Alpha and beta are the current gain factor or amplification factor. What? Current gain factor or amplification factor. So what? So we know the alpha formula. Alpha is what? It is a ratio of collector current to emitter current, it is called alpha. Beta is what? Ratio of collector current to base current. Okay. Now now see here, it is, we know just now I told you it is a form, and this form divide with the IC. Okay, if we divide with IC we get like this, and separate them. So separate here, separate it, and then these two gets cancelled. Then what do you get? We get this form. Okay, this form we get. Now just now I told you alpha is what? IC by IE, but it is in reverse form. That means it is reciprocal. Here beta is IC by IB. So here IB by IC means it is reverse form. Okay, so like this we write 1 by alpha, 1 by beta. Okay, why 1 by alpha? Alpha term is this one. 1 by alpha means reverse, IE by IC, IE by IC, IE by IC, that is why it is 1 by alpha, it is 1 by beta, beta form. Now we can write it is like this by taking LCM here. So it is a one relation. Or we can write from alpha is equals to like this also, from this form, and from beta also in terms of alpha. In terms of alpha, beta value is a beta. By doing this, bring this is the resistor 1 and take here LCM, then you can get this one, and take reciprocal, then this is the form. Okay, so this two alpha and beta are very very important, and most important form is this form is most important form. Okay friends, thank you for watching this video till the